For every microcontroller, whether it is 89C51, C52, whether it is 89C2051, these are all 40 pin IC, those are 20 pin IC, but for all the cases we need to have certain standard connections. Standard connections are at least the power supply section, which has been separately discussed, where we have a step down transformer and then we get 12 volt AC. That 12 volt AC passes through a bridge rectifier. That bridge rectifier gives me filtered a pulsating DC. That pulsating DC is further filtered, so I get a 12 volt DC here, and the 12 volt DC passes through a voltage regulator and we get 5 volt DC here, because the voltage regulator is 7805, and this LED is connected to indicate that the 5 volt DC is available. This is required when it is used in supply voltage from AC. If it is to be operated directly from the battery, we do not need the supply, as the microcontroller needs 5 volt. What we do, we take a 6 volt battery and connect a diode in series, which solves the purpose of supplying 5 volt to the microcontroller 40 pin, and 20 pin is always a negative. The other connections are very standard. There is a crystal which is connected at pin number 19 and 18, and there is a 33 PF capacitor, 2 numbers which are connected to ground, and the reset pin is necessary that we use the reset pin with a capacitor which is connected to positive terminal, the electrolytic capacitor positive terminal, and the negative terminal goes to the reset pin, and the negative terminal to a resistor goes to the ground. And we have a switch, we call it a reset switch, and the functions are that when the supply is switched on, that means whether through battery or through supply, when the supply is switched on, this capacitor from the positive supply starts conducting or charging, so this point goes high. Once this point goes high, initially this point goes high. After some time, the charging current through the capacitor will stop, because the charging will take place this way to ground. The charging current will stop. Once the charging current stops, then this point will remain at ground potential, because this is in the ground potential. So initially at the time of switch on, this point goes high. After that it goes to ground, that is negative. That is necessary for the program which is written here to start from the beginning. Otherwise the program may start from somewhere in the halfway through. To ensure that the program starts from the beginning, this arrangement has been made, the reset arrangement, which is a very standard connection for all the microcontrollers. We have connected a switch, a button switch, push to on switch. That means when I push, it will be on, when I release, it will be off. And this push to on switch at any time will discharge this capacitor naturally, because if I press this capacitor will be discharged. Once this discharged, again the capacitor starts charging through this. When I release this, again the capacitor will start charging through this, and again this point goes high, and then after the charging is over, this point goes to low. So the program again starts from the beginning. So every time I put the reset button, the program starts from the beginning. So that is the purpose of using the standard connections of the microcontroller like this. And pin number 31 is to be held high. That means this is connected to positive. Pin number 31 is held high always. That is for the purpose, if we wish to program it while it is in the circuit, then this particular pin will be used. Since we are programming it when it is externally, when we take it out, program it and bring it, so this pin, as per the manufacturer's data sheet, is required to be connected to positive point. So the pin number 31 is connected to positive point. So these are the standard connections.